So we get that theta equals to pi by 4. Now we have to put the value of theta over this new equation. So if you put the value of theta, cos pi by 4 will be 1 by root 2, sin pi by 4 1 by root 2, and all the values. Then after calculation we will get the new equation, that is the canonical form of our given equation will be x dash square into 4 plus y dash square into 2 equals to 4. That means x dash square by 1 plus y dash square by 2 equals to 1. Okay, clearly this is an ellipse, and we can say that it's an ellipse from the value of delta and d also. Both become not equal to 0. Delta was not equal to 0, and what was the value of d? D was greater than 0. So for both the values we can say this is an ellipse, and this is the required canonical form of the ellipse. Okay, so these are the only one this is the only one type of problem of that throughout that chapter, when delta is not equal to 0 and d not equal to 0. Now check if in some problem it happens that delta is equals to 0 and d is not equals to 0. Then check, there is no need to calculate the value of delta by d, right? Because it will be obviously equals to 0. And what happen if delta also equals to 0 and d also equals to 0? Then we will skip that process of translation, because then delta by d will become undefined, right? So in that case we will apply only rotation. So let's solve one problem like this, where delta and d both become equals to 0. So example 2, it states that reduce the following equation into its canonical form and determine the nature of the conic. It is x square plus 2xy plus y square minus 4x minus 4y plus 3 equals to 0. So what will be our answer? First we have to compare it with the general equation of second degree, which is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Then by comparing we are getting a equals to 1, h equals to 1, b is also 1, g will be minus 2, f is minus 2, and c equals to 3. Now we can easily calculate the value of delta and d. Delta is ahg, so 1 1 minus 2, h b f, so 1 1 minus 2, then gfc minus 2 minus 2 3. If you calculate the value you will get 0, and d is obviously 1 1 1 1, which is again equals to 0. So delta and d both 0. So we will skip the translation part here. That means we no need to calculate alpha beta here and the reduce from delta by d, because delta by d is undefined here, 0 by 0. So we will move to the translation, move to the rotation part. That is, we are giving a rotation of the axis through an angle theta. Okay, and check when delta and d both are equals to 0, that means the conic represents a pair of parallel straight line. So we can already found the nature of the conic. Now we have to find out its canonical form. So you can write it here that it's a pair of parallel straight lines. Okay, so now we are giving a rotation axis through an angle theta. So if you apply that rotation, the rule for rotation is x equals to x dash cos theta minus y dash sin theta, and y equals to x dash sin theta plus y dash cos theta. So apply it in our given equation. This becomes x square plus 2xy plus y square minus 4x minus 4y plus 3 equals to 0. So x dashed cos theta minus y dash sin theta its whole square plus 2 into this whole thing x dashed cos theta minus y dash sin theta into x dash sin theta plus y dash cos theta plus y dash square, that means x dash sin theta plus y dash cos theta its whole square minus 4 into x the whole thing minus 4 into y plus 3 equals to 0. Now we apply that rotation, that means we want to remove that xy term. So after removing, that means we have to consider the coefficient of xy terms. Now after calculation, you will get the coefficient of xy term will be two cos squared theta minus 2 sin squared theta equals to 0. That means cos squared theta minus sin squared theta cos 2 theta equals to 0. That is 2 theta is pi by 2. That means theta equals pi by 4. So this is the value of required theta. Now we have to put the value of theta over this whole equation. Okay, the whole thing. So after putting the value of theta, you will get, it will become 2x dashed square minus 4 root 2 x dashed plus 3 equals to 0. This is a pair of, this represents a pair of parallel straight lines, and this is the reduced canonical form of the equation. Okay, so this is how we solve the problems for this chapter. At first you have to compare it with the general second degree equation, get all the value of all the 6 constant, then compute delta and d. After that you will get the nature of the conic, that is what type of conic it is. Then you have to apply the specific formula to reduce its canonical form. So if both delta and d are not equal to 0, then it is a central conic. That means you have to find the center of the conic, which is alpha comma beta. To find the value of alpha comma beta, you need to consider the first 2 rows of the determinant delta and consider 2 linear equations of alpha beta. Solve it, you will get the center. Then the reduced form will become ax square plus 2hxy plus by square plus delta by d equals to 0. Okay, after translation at the to become the new origin alpha comma beta. Then we have to apply the rotation to remove xy terms by some angle theta. Apply the rotation rule for x and y. Then consider the coefficient of xy. This should be must be equals to 0. By putting this 0, you will get the value of theta. Put it in that equation. Then calculate it. You will get the canonical form of the equation. Okay. So this is the general rule for the problems of that chapter. And the only cases arise when check, that is delta and d both becomes equals to 0. Then this quantity will become undefined. So in that case, we will skip that step. That is the translation part will be skipped in that case. We will just from the original equation we will apply the rotation. Okay. So only this type of problems are here. Next one is example 3. Determine the value of a, small a, so that the equation ax square plus 6xy plus 9y square plus 3x plus 6y minus 4 equals to 0 may represent a parabola. Okay, So what is the condition for being a parabola? The condition is delta must be equals to not equals to 0 and d must be equals to 0. So we can easily get the sixth constant from that equation by comparing it with the general equation of second degree. Then we have to calculate the value of delta. Okay, at first compute the value of all that six constant. So check, a is here, a we have to find its value. So a, next h will be from here we will get h equals to 2, sorry, h equals to 3. Then b equals to by square, that means 3. Then 2gx, so g must be 3 by 2. Then f, 2fy, so it must be 3. Then what's remaining? C must be equals to minus 4. Now calculate the value of delta, you know that, and the value of d. Check, delta must be not equal to 0. By applying this condition you will get the value of a. Okay, so this is how we apply the procedure to get the nature of the conic and to get the canonical form of the conic.